Okay, so we're going to be dealing with a constant acceleration problem. And the problem goes, a particle moves along the x-axis with a constant acceleration of -4 meters per second squared. As it passes the origin moving in the positive direction of x, its velocity is 20 meters per second. So in this problem, time t is measured from the moment the particle is first at the origin. At what distance x and time t does v equal 0? At what time is the particle at x equals 25 meters at x equals -25 meters? And also, we have to try to find the velocity of the particle at x equals 55 meters. So as usual, the way we start this problem is by taking a look at our given information, okay? So the given information here is the acceleration, -4 meters per second squared, the velocity of the particle, which is 20 meters per second. In fact, this is the initial velocity of the particle, so we can write that as, let's see, v0. And this initial velocity of the particle is at x equals 0. Okay, so over here, this is just a restatement of problems A and B. In essence, problem A is asking us when and where is the velocity equals 0. And problem B asks, when is the particle at x equals 25 meters, at x equals -25 meters, and it also tries to get us to find v, the velocity, at x equals 55 meters. Right, so over here, you can see that I've drawn the particle, and I've labeled its velocity with a green arrow directed at the positive direction of x. So this is a positive direction of the x-axis. The acceleration, on the other hand, because it's negative, we represent it with a leftward facing arrow, right, and opposite to the velocity. So it's going to be slowing down the particle the further and further away the particle goes. So we're going to take a look at the formulas and try to find which one of these formulas is going to be the best to use to solve problem A. We determine this by taking a look at what problem A is really asking. It's asking us a when question and a where question. It's also telling us that the velocity of the particle is to be 0. So immediately that lets us know that we have to use a final velocity formula. Also, we have to use the distance formula so that we can solve for what distance is the particle's velocity equal to 0. So let's go ahead and try to solve problem A. So the way we're going to solve problem A is by taking a look at these two formulas, the distance and the final velocity formulas. Specifically, we're going to start with the final velocity formula. The reason is because, if you can see, we can solve immediately for t and then plug it into the distance formula to get x, right? V sub f is equal to 0. That's what's provided by the problem. At what distance x and time t does v equal 0? So we can take this v equals 0, right? Stick it right here, solve for t. Once we have t, we can plug it in here and get x. So let's go ahead and do that, right? So we have 0 is equal to 20 meters per second, and then minus 4 meters per second squared times t, right? 20 here is our v0, and the minus 4 meters per second squared is the acceleration. So over here, I'm going to get 4 meters per second squared times t is equal to 20 meters per second. If I divide both sides by 4, I get t is equal to 20 meters per second divided by 4 meters per second squared, and this comes out to be 5 seconds. Oh, whoa, not that. 5 seconds. Okay. So t is equal to 5 seconds. So this tells us that at t equals 5 seconds, the particle comes to a stop and, in fact, reverses its trajectory. It turns right back around. So next we're going to have to solve for where that occurs. So first let's divide this. Let's put a nice little divider here. Okay, so we have t, so we can solve for x. X is going to be equal to 20 meters per second multiplied by t, and t is what? 5 seconds. So times 5 seconds, and then plus 1/2 a. A is our acceleration, so that's -4 meters, -4 meters per second squared, and then times t squared. t squared is going to be 5 seconds squared. So 5 seconds squared. Now x0 is equal to 0, right? So we don't need to worry about that. That's the initial position of the particle. So since it's 0, we just neglect it. So this means we're going to have x is equal to 20 meters times 5 seconds. That's going to be, 20 meters per second times 5 seconds. That's going to be 100 meters. And then over here, we're going to have half a negative 4. That's going to be negative 2, right? So minus a 2 meters per second squared times a 25 seconds squared. So this here comes out to be a 50 meters. So we're going to have x is equal to 100 meters minus 50 meters, which is equal to 50 meters. So at x equals 50 meters, the particle comes to a complete halt because its final velocity is equal to 0. Okay, so last but not least, part B. So as you can see, part B might be a bit of a handful. And part B states, at what time is the particle at x equals 25 meters, x equals negative 25 meters? Try to find v, the velocity, when x is equal to 55 meters. So we have our given information here. And the formula we're going to be using is the distance formula. So I've divided the screen up so we can solve for the case with x equals 25 on the left side and x equals negative 25 on the right side. So we begin by plugging in 25 into x. So we have 25 is equal to v0t. Now v0 is equal to 20, so we'll have 20t. And then plus half at squared. A is minus 4, so we're going to have minus 2t squared. x0 is just 0, so we neglect that. If we rearrange this, we're going to get 2t squared minus 20t, and then plus 25 equals 0. Now we can make use of the quadratic formula here, and I'm not going to do this step by step just to save time, but we're going to end up with two values of t. Our first value is t is equal to 5. We have 5 plus square root of 25 over 2, and that's approximately 8.5 seconds. And then we have t is equal to 5 minus square root of 25 over 2, and that's approximately 1.46 seconds. So we have two solutions for this first part, right? And the reason is you have two solutions, two separate times, is because the particle is going to pass that x equals 25 meter mark twice, right? It's the same scenario as if a car passes by your house one time, slows down, reverses, and then passes by your house a second time. That's all that's going on. So it first passes x equals 25 meters at 1.46 seconds, and then it passes back. It goes and then stops and then turns around and passes back that same point at a later time, 8.5 seconds. All right, so let's go ahead and try to solve for x equals minus 25 meters. So the same way we solve for this one, we plug in minus 25 meters, and that's going to be equal to 20t minus 2t squared. So we rearrange this again, and we have 2t squared plus 20t. I'm sorry, that should be a minus 20t. So minus 20t, and then minus 25 is equal to 0. And for this, we get t is equal to 5 plus square root of 75 over 2. And that's going to be approximately 11.12 seconds. And our second solution is t is equal to 5 minus the square root of 75 over 2, which is approximately minus 1.12 seconds. Now, we're going to X this guy out. And the reason we X out the bottom solution here is because it's negative time. If you recall at the beginning of the problem, right, we said that t, the time, starts at t equals 0, right? So it starts when the particle crosses the origin. So that occurs at t equals 0. So there's no negative time that we're working with here. So our solutions for the times are going to be here, 8.5 seconds and 1.46 seconds, and also here at t equals 11.12 seconds. Now, the last part of this problem tries to get us to find v when x is equal to 55 meters. So the equation that we're going to be using is the third equation. 2a times x minus x naught is equal to v sub f squared minus v sub naught squared. So again, the way we're going to do this is simply by plugging in the values and seeing what comes out. So we're going to have 2 multiplied by a is negative 4, and x minus x0. So x0 we already know to be 0. And our x here, according to the problem, should be 55 meters. So we have 55 minus 0, and that's going to be equal to the final velocity squared. So that's what we're trying to solve for here, right? Try to find v when x equals 55, and minus the initial velocity squared. So that's going to be a minus v0 squared, so 20 squared here. And I'll just go ahead and write that as 400. So vf squared minus 400. Let's take this guy out. Okay, so we arrange this and we get vf squared is going to be equal to 400, and then minus 2 times 4 times 55. So this is all going to be 400 minus 440. So this is going to be in units of meters squared per second squared. So that gives us Vf squared is equal to negative 40. So negative 40 meters squared per second squared, which means that our final velocity, Vf, is equal to the square root of negative 40 meters per second. Now, obviously, square root of negative 40 isn't real. This is a complex number. So what does this tell us about trying to find v when x is equal to 55 meters? Well, for one thing, it tells us that the particle never reaches x equals 55 meters. If it did, then our solution for vf would have been a real number. However, because this is a non-real number, right? The square root of a negative number is a complex number. So because this is non-real, this tells us that the particle, the particle never reaches x equals 55 meters.